Let's look at the operator interface um, next. And so the operator interface defines all of the potential um, values and triggers that might be provided by a joystick, a controller, a button panel, or software dashboard, whatever it happens to be. And so some of these are evergreen. They make sense all the time, especially some of the drivetrain ones like X, Y rotation. Um, Maybe not Y if you have a differential drivetrain. Field relative buttons, resetting gyros, resetting the pose to the vision, X stance again for swerve, um, driving slow versus fast, locking to an angle. These are all sorts of different examples. Seeing if vision is enabled, sysid, which we'll talk about later, but those are all defined here. Some of these are game specific, like a drive to pose feature. There is an example drive to pose in 3061 lib that we'll look at later when we get into commands, a way to override that, a way to log the current pose, which can be useful for a certain type of on-field calibration, interrupting everything that's currently running and getting back to a known state. Some of them might be more delegated to operators, perhaps through like a dashboard interface, enabling, disabling, switching between primary and secondary sensors, um, having auto scoring, enabling and disabling. We added in a couple examples here for the XRP with the servo-based arm. There's a couple examples here for the elevator, just to make that a more comprehensive example. Um, there can be as many of these as we want. You'll notice they all return new trigger false, or they make a new trigger that always returns false, so it won't actually trigger any commands. And if the classes that implement this interface don't override one of these methods, then they'll just never generate a command, which is fine. Um, and so that's nothing to worry about. So we don't have to worry about having like too many of them or something necessarily. Um, we won't look at all the examples, but you can see, for example, here, there are many different subclasses. So dual joystick OI, here's a subclass that has two joysticks, a translational joystick and a rotational joystick, designed for like a swerve drive. And so now it overrides a bunch of these methods and connects them to either getting different axes of the joystick or triggers from specific buttons on the joystick as well. So here's an example here of when you have two joysticks. We have another one here when you just have a single Xbox controller and you still want to control your robot. Again, overrides the methods. So this allows us to swap different types of joysticks and controllers and still control things. We ended up this last year creating a different class for simulation because often our simulation needs are different and we're limited a little bit in terms of the buttons in simulation. You can use the keyboard simulator mapped to joysticks, which is what we do. So we have two joysticks here, but they're really just mapped to the keyboard. And we use those and the four buttons on the keyboard that are mapped to each joystick to do different types of testing here. Another interesting class is this one, the operator dashboard. The operator dashboard here implements the operator interface, but it does not model an actual physical joystick controller button panel. It models a software-based dashboard like an Elastic. And so it uses a modified version of the log tunable Boolean class, which is from Mechanical Advantage, which we've modified to be able to create it in such a way that it always will be read and writable, even if tuning is set to false, which is exactly the behavior we would want for our operator dashboard, like software dashboard. And so here you can see we have example buttons for enabling, disabling vision, switching between primary and secondary IR sensors, like on a manipulator or collector. So some examples of that as well. The OI selector class, this is the class that is responsible for detecting if the operator interface has changed in some way. And so whenever we want to interface with the operator interface, we call this get operator interface static method. What this method does is it checks if the joysticks have changed not just joysticks. That could be named better. And if so, it clears the active button loop, finds the new operator interface, and returns that. And you may remember from Robot Container that if the operator interface does change, we will remap all those triggers to buttons, or all those triggers to commands, rather, to make sure that the new joysticks, controllers, whatever, will properly control the robot. Um, and so this code, originally I think came from Mechanical Advantage a few years ago, in terms of checking through the drivers, using the driver station to check, are new joysticks present, have they changed in some way. It keeps track of all of that and which ports they're in and all of those things, and then based on that, it will generate different warnings and stuff as well. So for example, and this would need to be updated from year to year, but like if it doesn't detect like our competition, like our driver or operator console configuration, we want a warning there. Something's not right. The robot isn't going to behave as we expect. And so we have a non-competition interface warning here that if it's not the one it should be, which this last year was the dual joystick OI. But if we're in simulation, like we don't care about that, so we don't worry about it. And then if there's nothing plugged in, we generate a different alert for that case as well, saying like, hey, we've got no joysticks, which is a different type of problem. So um, clever class here. This is a cool feature, where it gives us some flexibility so that we can run a practice robot with an Xbox controller, the real robot with the operator console, simulate the robot with um, dual joysticks modeled through keyboards in the simulator. It's all great. So one last thing I realized I should have mentioned, the operator dashboard does implement the operator interface and has all of that. Since we want the operator dashboard to work in conjunction with either two joysticks or an Xbox controller or whatever it happens to be, it's important that the dual joysticks OI class actually extends operator dashboard and doesn't just implement operator interface. So you'll see that like right here, and you'll see that with the simulation thing as well. That's really important so that we don't, we want the dashboard, the software-based dashboarding elastic and the actual physical controllers.